Hey everyone, today we are going to be looking at inequalities. Our learning goal for today is that we will be able to write an inequality from a given scenario and that we will also be able to graph an inequality on a number line. You may remember from elementary school they called inequalities alligators. We're no longer going to call them alligators, but just to try to give you a preview of what is to come and to connect with something you already know. Words to know for this lesson is the word inequality, equal to, greater than or equal to, less than or equal to, not equal to, and solution set. And we will be talking about these throughout the video today. Let's start by looking at what each inequality symbol means. The first symbol in the chart is the less than sign. We could say that 9 is less than 12, for example. The next symbol in the chart is called the greater than sign. We could say that 12 is greater than 9. The next symbol in the chart is the less than or equal to. When you see the sign right there underneath, that represents the equal to value. So for example, we could say that x, an unknown, is less than or equal to 10. The next symbol is the greater than or equal to, and once again you can see underneath there is the equal to sign. We can say that x is greater than or equal to 10. And the last symbol in the chart is the not equal to. When you see the equal sign with a slash through it, it means not equal to. And you could say that 5 is not equal to 6. And in your chart on your page, you actually have the equal to sign. So you can just simply write that that is equal to. Let's try writing a few inequalities from situations given to us. So in this problem, it says 7 is less than or equal to 23. So I have to think, what does less than or equal to mean? So 7 is less than or equal to 23. The next one, 56, is greater than 28. So I'm looking at the words greater than. So 56 is greater than 28. Why don't you pause the video now and try the next 3 on your own and then restart the video to see if you got the same answers. So, how'd you do? Check your answers with mine above. Now let's write the meaning of inequalities out into words. So we're doing the opposite of what we did on the previous slide. So this first one is saying 7 and 8/10 is not equal to 23 and 7/10. Question B says 8 and 1/3 is less than or equal to 8 and 7/10. Why don't you stop the video now and try C, D, and E on your own, and then restart the video. Now check your answers and see how you did. If you missed any, write them down in the question section of your notes. Now let's look at some real-world examples of the use of inequalities. So as I'm reading the sentence, I'm going to underline important keywords that help me determine which symbol to use. So on A, it says you must be older than 13 to play in the basketball league. Older than 13 helps me decide what type of symbol I will use. It doesn't say that I can be 13, so it cannot be equal to. So I must decide that I have to be older. So that means it has to be the greater than symbol. And since I don't know the age, I'm going to use the variable x. So for A, I wrote x is greater than 13. Now let's look at B. To use one stamp, your domestic letter must be under 3 5/10 ounces. Must be under. So that means it cannot be greater than, it cannot be equal to, it must be under. So for that answer, I wrote x is less than 3.5. And let's look at C. You must be over 48 inches tall to ride the roller coaster. It doesn't say I can be 48 inches tall. It says I have to be over 48 inches tall. So I wrote x is greater than 48 inches. And I also noticed that I forgot to label the first two. So I'm going to go back real quick and label them. So when we were talking about inequalities, there is more than one answer for some inequalities. So these are called solution sets. So if I'm looking at this first problem, it says, look at the two inequalities, x is greater than 3 and x is greater than or equal to 3. Describe the solution sets for each. So when we're talking about solution sets, we want to know every number that could be x. So if we think about this, I could say the solution set for this would, for the first one, and I'm going to use the color blue for this one, that x could be any number 4 or greater. Okay, and some people might write it this way. They will say 4 to infinity, because infinity represents any number greater. Okay, now looking at the x is greater than or equal to, I could say this can be 3 because it has that equal to sign. So the number can be 3 or any number that's greater. And once again, you could say 3 to infinity. Okay, let me make a better infinity symbol because that one is not very pretty. There we go. Okay, why don't you try the ones on the bottom? So pause the video and try the ones on the bottom. If you have any questions, leave them in your notes. One way to represent solution sets is by creating a number line. Let's start by discussing this first problem. So it says x is less than or equal to 0. First, we need to discuss what does it look like when I actually plot a point on an inequality. There are two types of ways to create points. There is what we call a closed circle point, which represents that something is equal to that. So in this problem, we are going to use a closed point. And we're going to plot that point at 0. Then we must decide which way will our ray to represent all the numbers that x can equal. So if it's less than, I want my line to be going to the left because x has to represent every number less than 0. So x could be -10, x could be -6, any of those. Next, let's look at the problem below. We have x is greater than -1. The greater than or less than symbol has a different type of point because it doesn't say that it's equal to. So we call this an open circle. It is an open circle because we do not want to count -1 as one of the solutions to the problem. So I'm going to go to -1, which will be right here in between 0 and 2 because these are counting by ones, and I'm going to put a circle around the -1. And then this time I want it to be greater than. So I want my line to be going to the right this time with an arrow to represent that it can be any number greater than. Let's try a few more together. So x equals 8. In the last one we talked about that a closed circle represents equal to. So I'm going to go to 8 and put a point, a closed circle point on 8. Then I have to decide, can 8 be anything else? If yes, then you're going to draw a ray to represent the solutions. But since x equals 8, it'll only be a point on 8 because x cannot equal anything else. Why don't you try the next two, pause the video, and then unpause it when you are done to see if you got the same answers I got. Welcome back. Hopefully you are ready to check your answers. So we have x is greater than or equal to -5. So I'm going to go to -5 and I'm going to put a closed point. And since it is greater than, I'm going to go towards the positive numbers because I need numbers that are greater than -5. Now looking at the next one, I have x is less than 5. So I'm going to go to 5, which is in between 4 and 6. This time I'm going to have an open circle. And if it's less than 5, I'm going to draw my line to the left to represent all the numbers that are less than 5. Could be possible answers for x. I'm only going to do one with you on this page, and I'm going to leave the others for you to do in class and ask questions with your group. I would like to look at E, when it says x cannot equal 4.2. So 4.2 is going to be in the middle between 4 and 5. So we're going to say 4.2 is about right there. So what we are going to do, it's going to be an open circle because we do not want it to be 4.2. And we are actually going to have lines going both directions because it could be anything. It could be numbers that are greater than 4.2. It can also be numbers that are less than 4.2. So this time we have rays going both directions. Now you try A, B, C, and D on your own. We are almost done. This is the last thing we were going to talk about, and then I have a practice slide on the next slide for you to work on your own. So now we are going to write an inequality from a graph. The first thing we have to look at is where is our point? Our point is on the 15, and we have to look, is it a closed circle or is it an open circle? This one's a closed circle, so that means it's equal to. First thing we need to write is x. You can use any variable. I'm going to use x for this first one. So x, and then I look which way is my arrow. So there's a darker arrow. You can see it is going this direction right here. So that would mean that it is everything that is less than 15. So I know x has to be less than, but since it's a closed circle, it has to be equal to as well. Then we have 15. Okay. Let's do one more together. Let's do B, and then I'll leave C and D for you to pause and try on your own. So if I'm looking at the point this time is in between 16 and 17, so we need to think what number is between 16 and 17, which would be 16 and a half. So once again, I'm just going to pick a letter. I'm going to pick the letter B. Then I need to look, what direction is my arrow going? This time it's going this way. So I'm going to say B is greater than 16 and a half. And it's not going to be equal to because once again, if it is an open circle, it cannot equal that number. Why don't you pause the video and try C and D on your own and then come back and check your work. I hope you paused the video and are back. I have the two answers. The only one I'm really concerned about that you might have tripped up on is this one. You see the point is at 23, but if you look closely, you can see that the arrows are going both directions. So remember in the last slide we talked about that meant not equal to. And it's the same thing in this side. These are 3 problems for you to try on your own, and then we will talk about them in class. Your to-do list before class is to complete the notes. Write down any questions that you may have about something that was confusing or you didn't completely understand, and be prepared to discuss your questions with your group.